questions 21 through 25 on the 2016 grade 10 AMC 10B. What is the area of the region enclosed by the graph of the equation x squared plus y squared is equal to the absolute value of x plus the absolute value of y? Well, we have to first graph this, and then once we do, we will be able to figure out the area. So in order to graph this, I'm just going to concentrate on one quadrant. So if this graph is in all four quadrants, let's just concentrate on the first quadrant, and that is when x is greater than 0 and y is greater than 0. When that is the case, that equation becomes x squared plus y squared is equal to x plus y. And this is a little bit better to work with than this, so let's proceed. This, if you put it all on one side, becomes x squared minus x, y squared minus y is equal to 0. And at this point, I'll do something called completing the square, and completing the square will allow me to graph this equation. It'll be a little bit more helpful. So what you do is you take the coefficient before x, which in this case is -1, take half of that, which is -1/2, and then you square it. So when you square -1/2, it becomes 1/4, and then immediately you have to subtract that. Completing the square with the y is the exact same thing, plus 1/4 minus 1/4, and that equals 0. And that allows you to factor this and this very nicely. X minus 1/2 squared plus y minus 1/2 squared. And then this and this we can put on the other side. It's basically 2/4, which is going to be positive 1/2. So this is a circle with radius square root of 1/2. So if I were to just draw the first quadrant, and we have to label the center of this circle, which is 1/2, and then we have to draw the circle in a way so that the radius is equal to the square root of 1/2. So r squared is 1/2, so r will be the square root of 1/√2. If you rationalize the denominator, it's √2/2. So the graph looks something like that. But the key thing is that it's only got to be in the first quadrant, so I have to get rid of that portion of the graph because it cannot be in any other quadrant. So there we go. That is what it looks like just in the first quadrant. And if you use this equation, you can also get the x and y intercepts, and you get 1 being the x-intercept, which I have labeled here, and y being the 1 being the y-intercept. All right, well, when you do the exact same thing in all the other quadrants, you get the following shape. And as you can see, just as before, quadrant 1 is pretty much a part of a circle, but then all the other quadrants are also, in a very similar way, parts of circles. So now we have to calculate the area of this region. So to do that, there's a few ways, but I'll just do it in a simple way, which is connect these points, and when you do, you will get a square. And then, of course, on top of each side is a semicircle. So the area of that region will be the area of the square, which will be, of course, x squared, if that is the length of the side. And then we have 4 semicircles, so that's 2 circles. So 2 times pi r squared. So here we go. From here to here is 1, and so is that. So we can easily figure out x using Pythagoras. 1 squared plus 1 squared is x squared. So x squared is equal to 2, so x is the square root of 2. So a is equal to x squared, which is just 2. And then now we have 2 pi r squared. Well, r is the distance from there to there. X basically represents the diameter of those semicircles. So since x represents the diameter, the radius will be half of x, and that's √2/2. So we have root 2 over 2 squared. So this is 2 plus 2 pi. Root 2 over 2 is 2 over 4. And therefore that becomes 4 over 4, which is just 1. So 2 plus pi. There we go. 2 plus pi is the area of the region that is enclosed by that graph. And therefore number 21, the answer is B. A set of teams held a round-robin tournament in which every team played every other team exactly once. Every team won 10 games and lost 10 games. There were no ties. How many sets of 3 teams, A, B, C, were there in which A beat B, B beat C, and C beat A? Well, there's 20 games, 10 games and that are won and 10 games that are lost. So the first thing I have to do is figure out how many teams there are. Well, there was 20 wins and losses combined. And let's just say the number of teams is n. Well, the number of games is n times n minus 1, right? Because each team plays every other team once. So this is the equation that allows us to figure out the number of teams. The n's cancel. So I have n minus 1 is equal to 20, therefore n is 21. So there's 21 teams. Okay, so the first thing I want to do is the total number of subsets. The total number of subsets where subsets are of the form A, B, and C, 3 teams. Well, since there's 21 teams, from 21, choose 3 teams. And that will give me the total number of subsets. And when you do that calculation, it's 1330. All right, so that's the total. But I'm not interested in the total. I want to know this specific situation where A beat B, B beat C, and C beat A. All right, well, the subsets that satisfy that condition, if you have a scenario where A beats B, B beats C, and C beats A. So basically, it's like a circle, right? A beats B, beats C, and C beats A. So this is the subset that would be what we're interested in. And the other subset is basically that doesn't not satisfy the condition, is any subset in which one team beats the other 2 teams. So for example, A beats B, but then A also beats C. So we have A goes to B and C. It beats both those teams. So what we have to do is figure out how many are in this category, subtract it from this, and that will give me this. And it's a little bit easier to figure out this, so that's what I'm going to figure out. So how do we figure out this calculation? Well, there's 21 teams in total, right? So for A, I have 21 choices for that first team. And then let's just say I choose a team, call it Team A. That team, which I have been called A, if you remember, each team wins 10 games. So it won 10 games. And of those 10, choose 2 to represent its win against C and its win against B. So that pretty much means from those 10, choose 2, and that, when you do the calculation, is 45. So to figure out the total number of subsets of this form, it would be this 21, the number of choices for that first team, times this 45. And that is 945. All right, so now we're down to the final step, as you take this 1330 and subtract from it 945, and that gives you how many subsets satisfy that condition. So 1330 minus 945, and that is 385. 385, therefore, for number 22, the answer is A. In a regular hexagon ABCDEF, points W, X, Y, Z are chosen on sides BC, CD, EF, and FA respectively so that lines AB, ZW, Y, X, ED are parallel and equally spaced. What is the ratio of the area of the hexagon WCXYFZ to the area of the hexagon ABCDEF? Well, let's draw a diagram and try to explain this question. So here's our hexagon, and then I'll chop it into segments to try to figure out this area. And since we are pretty much figuring out ratios at the end, we can give it any sort of number. So I'll just call the side 1. And now, of course, we have a whole bunch of 30, 60, 90 triangles because this is a right triangle. And internal angles of hexagons are equal to 120. And some of you know that, and some of you don't, but if you didn't, now you know. So that means this is 30 since that's 90, and there's 60. So again, we got a 30, 60, 90 triangle. And I'm going to spare you the pain of listening to me go through 30, 60, 90 triangles for the 1000th time. I don't think you need me to go through it. So I'll just call this part Y and this part X. So we'll calculate Y and X using the ratios 1, root 3, and 2. And when you do, you get Y is equal to root 3 over 2, and you get X is equal to 1/2. So now we're ready pretty much to calculate the area of this full hexagon. The area will be the big rectangle in the middle, so 1 times 2Y, and then add to that 4 of those triangles, so 4 times 1/2 base times height, and each of those has a base of X and a height of Y. Substituting our values for X and Y, you get root 3 plus 2 times 1/2 times root 3 over 2. So this is root 3 plus root 3 over 2, and that's 3 root 3 over 2. 3 root 3 over 2. All right, so that's done. Now we have to concentrate on the other guy, this one right here. Now the key thing is that when they say that these lines are being drawn, they're equally spaced, that part that they're equally spaced really helps us out with regard to where they are. When they're equally spaced, that means the lines ZW and YX will chop that red line into 3 equal parts. So something like this, like that, and like this, approximately like that. So if I label this, I've got Z here, W here, and then Y and X. And the endpoints were F and C. So for example, if this is B, this is also B, and this is also B. That's what they mean by equally spaced, like that. So now our responsibility is to figure out the area of WC X, Y, F, Z. So it's basically this guy in the middle. Okay, there's a few ways of doing that. What I'm going to do is I'm just going to calculate the top and bottom segments and then subtract it from the full, and that will give me W, C, X, Y, F, Z. Okay, well, the first thing is, of course, 3B is equal to 2Y, right? From here, this was Y. So the reason I wrote that is because Y I already know is root 3 over 2. So 2Y is root 3. And therefore, B, very quickly, we can get as root 3 over 3. And then this, from here to here, I'll just label that A. And A I can get very simply by the fact that A over B, again, is the same 30, 60, 90 ratio. You'll notice this triangle is also a 30, 60, 90 triangle. So that ratio of A over B is 1 over root 3. So that means A will be equal to root 3 over 3 over root 3. That means A is a third. Okay, so now I can get the area of those two top and bottom shapes. So that will be as follows. area of the top and bottom will be 4 of these triangles. See these triangles? 4 of those. So that's going to be 4 times 1/2 base times height, which is a times b. And then 2 of these rectangles, which are, well, that was 1, so 2 times 1 times b. This is a is equal to 2 times a, which is 1/3. B is root 3 over 3. And this is 2 times b, which is root 3 over 3. So this is equal to 2 root 3 over 9 plus, let's get a common denominator, top and bottom by 3. So 6 root 3 over 9. And that is 8 root 3 over 9. Okay, so now I'm ready to figure out that middle portion. That middle portion, which is what? W, C, X, Y, F, Z, is the entire one, which is that. So 3 root 3 over 2 minus what I just figured out here. So minus 8 root 3 over 9. Okay. So obviously we got to get a common denominator, top and bottom by 9 here, top and bottom by 2. So that's going to be 27 root 3 minus 16 root 3 all over 18. And that is 11 root 3 over 18. And then the final step is we got to figure out the ratio of W, C, X, Y, F, Z over the entire hexagon, which was A, B, C, D, E, F, I believe. So that's going to be 11 root 3 over 18 over 3 root 3 over 2. And if we invert and multiply, we get 11 root 3 over 18 times 2 times 3 root 3. So the root 3's go, and I think I'll get, this will cross with that to get 9. And then 9 times 3 is 27. So 11 over 27 is the answer to this question. Therefore, number 23, it's choice C. How many 4-digit positive integers, a, b, c, d, with a not equal to 0, have the property that the 3 2-digit integers a, b less than b, c less than c, d form an increasing arithmetic sequence? One such number, 4692, where a is 4, b is 6, c is 9, and d is 2. All right, well, A, B, C, D is our number, and they've given us that AB must be less than BC, must be less than CD. And also, for that to happen, A's got to be less than or equal to B, has got to be less than or equal to C. Okay, where all 3 integers, if we were to write them in proper format, that's 10A plus B, that's 10b plus c, and that's 10c plus d. And because they're an arithmetic sequence, they are of the form a plus d, a plus 2d. And a plus d minus a is equal to just d, and a plus 2d minus a plus d, if you subtract it like that, is also d. So that helps us to try to get some sort of an equation here. So that means the second term minus the first term, 10a minus b, is equal to the third term minus the second term. Like that. Okay. So let's see here what we get. 2c minus b minus d is equal to 10c minus 20b plus 10a. And if I factor the other side, this side I don't think there's much I can do, but this side I can factor out a 10. And when I do, I get c minus 2b plus a. All right. So at this point, we have to start thinking, what is it that we can actually do with that information? It's nice to have it factored, but does it help us? Well, obviously 2c minus b minus d, which is the left side, is a multiple of 10. And what that does is gives us a few limited cases. The only possible cases are where the right side, which is c minus 2b plus a, is either to equal either 0 or c minus 2b plus a can equal 1. And those are the only ways that we can make this work. So, based on that, we now have to start playing around. For the first case, with a whole bunch of trial and error, putting in numbers, you get the following. You get either 2, 5, 9, 3 for my ABCD, or 4, 6, 9, 2, 6, 7, 9, 1, 8, 8, 9, 0. We also have 1, 4, 8, 2, 3, 5, 8, 1, 5, 6, 8, 0, and one more is 2, 4, 7, 0. So that's what, 7? 8 actually. And then for this guy here, where c minus 2b plus a is 0, ones that work are 1, 2, 3, 4, 1, 3, 5, 7, 2, 3, 4, 5, 2, 4, 6, 8, 3, 4, 5, 6, 3, 5, 7, 9, 4, 5, 6, 7, 5, 6, 7, 8, and 6, 7, 8, 9. So that gives me another, what, 9. So 7 here, 8 here and 9 there, that's a total of 17. And therefore, number 24, the answer is D. Let f of x equal the sum from k equals 2 to 10 of kx bracket minus k times bracket x, where bracket r denotes the greatest integer less than or equal to r. How many distinct values does f of x assume for x greater than or equal to 0? So for example, 5.6 bracket is equal to 5. It's the greatest integer less than or equal to the value inside the bracket. So what we have here is something that we need to figure out. How does this behave? So what you do is you look if there's any sort of a periodic nature to it, and if so, what is that and what is the period? So let's see what we get for x plus 1. This would be k equals 2 to 10, and it would be kx plus 1 minus k x plus 1, like that. And this is k equals 2 to 10. And if you multiply this, you get kx in the bracket plus k in the bracket. And then this side becomes minus kx inside the bracket minus k inside the bracket. Well, this guy and this guy cancel, so all you're left with is k equals 2 to 10 of kx inside the bracket minus k times x inside the bracket. Well, this right here is pretty much f at x. So it's really just k equals 2 to 10 of f at x. Well, actually, the whole thing is f at x, so I don't even need to put the summation like that. That's pretty much what I meant. So what this tells me is that f at x plus 1 is the same as f at x. So that means f at x is indeed periodic, and it has a period of 1. So basically, when you go from 0 to 1, let me just draw something basic. This is certainly not what it looks like, but just for the sake of explanation, let's say you have 0 to 1, right? And the graph looks something like that. Well, that means it's going to look like that every single period of 1. So from 1 to 2, again, it would look like that from 1 to 2. And then 2 to 3, it'll look like that. So that's what they mean, where f is periodic with a period of 1. Another example that probably a little bit closer to your memory is those sine and cosine graphs. You remember how they are basically the same? And if you remember, those are the same. This is, for example, sine x. And as you can see, it's also periodic, meaning it repeats itself. And its period, if you remember, what is that point? 360 degrees, or sometimes also referred to as 2 pi in radians. So that's what we figured out with this calculation here. Okay, so now we must move forward with this important piece of information. That means all the values that you need to know for f of x are really just between 0 and 1. Just like how in the sine graphs, all the values you really need to know would be between 0 and 2 pi, because the rest is always the same. So in a sentence, the number of distinct values of f of x f of x assumes is the same as the number of distinct values that f of x assumes in that period from 0 to 1. All right? So hopefully that makes perfect sense. And for this interval, the value of bracket x would be 0, right? Because all those numbers are decimals, like 0.3, 0.7, and if you take the greatest integer less than it, it's 0. So that means that this whole thing, which is f of x, really just reduces to the following: 2 to 10. Since x is going to be 0, this becomes 0. So all you're left with is just that kx in the bracket. And that's it. And for this function, which is of that form, that function will have a number of values, and those values can be calculated by substituting values of x, and those values of x obviously have to be between 0 and 1 inclusive. And if you look at this carefully, you'll see that they are going to pretty much be all fractions between 0 and 1. And since k is going from 2 to 10, you'll be able to calculate that those fractions are these ones right here. And these are the distinct values. There's going to be some repeats, but the repeats have been taken out. And that totals 31. And then you also have to add one more value when x is 0. And therefore, that gives you 32 distinct values. And the values really that we were substituting were anything of the form x is equal to 1 over k, or 2 over k, or 3 over k, ... all the way until you got to k minus 1 over k. Just in case you're wondering, how did they come up with these fractions? And in our question, k was from 2 to 10, as you can see from the summation. So 32 is the answer to this challenging question, and that would mean that number 25, the answer is A.